4.1 Properties of Quadratic Functions. So far we've learned how to solve quadratic equations, but it's always best to learn about these equations and functions in the context of both symbolic, okay, using the algebra to solve, but also getting to know what these quadratic functions look like graphically. So just remember, this is nothing earth-shattering or new, but a quadratic function is any function that can be written in the form y equals ax squared plus bx plus c, where a, b, and c are elements of the reals, so they can be any number that's real, remember, just not imaginary, and a can't equal 0, because if a equals 0, if I would scratch that out, we would oh, hello, well, jumpy. We would simply have a linear equation instead of a quadratic one. And if you find it in the form y equals ax squared plus bx plus c, this is called the general form. Now we're going to be learning something about the standard form, but that comes a little bit later. So remember from grade 10, functions, for every x value there is only one y value. So when we graph the parabola, we should be able to draw a line and move it across the entire graph or function, and it will pass the vertical line test, meaning that the line or the graph of the line will only touch once. So this is called, so y equals x squared is called the parent graph, or sometimes I like to call it the mother function. This is what all of the parabolic graphs are first based on. So what I want us to do first is just to explore what a graph of y equals x squared looks like. So I'm going to choose some x values here. And I'm going to say 0, -1, -2, -3, sorry, not negatives anymore, 1, 2, and 3. So when I say x equals -3, I'm going to plunk it into my graph here, or plunk it into my equation y equals -3 squared. All I'm doing is I am taking the equation and substituting in my x value. Y equals -3 squared, and since the base is -3, -3 times -3 is simply 9. So when x equals -3, y is going to equal +9. And when x equals -2, I'm going to substitute in for my x -2. So y equals -2 squared. Y is going to be 4. So in my table of values here, I'm going to write in a 4, not type. That's funny. What happens when x equals -1? Y then equals -1 squared, which equals +1. Similarly, if I put in 0 in for my x squared, y is going to be 0. And if I put in 1 as my x, y is going to be 1. If I put in +2 as my x, 2 squared is going to be 4. And if I put in 3 for my x, y is going to be 3 squared, which is 9. So let's plot this thing. I am going to say for every box is going to be worth 1. Now this is good enough. This is sufficient enough to show my scale. I could go 1, 2, 3, and all the way like -1, -2, -3. But if I put in 1, 1 in my x axes, on my x-axis, and 1 on my y-axis, don't forget to label them, that is sufficient to show scale. So now I'm just going to plot these points. So now let's graph this thing. I know that I need to get up to 9, and let me count. 1, 2, 3, 4, 5, 6, 7. I don't have 7 in my y direction, so what I'm going to do is I'm going to go up by 2. 2, 4, 6, 8, 10. And in my x direction, I'm just going to go 1, 2, 3. Now this is sufficient. In all honesty, I don't even need to put anything other than this to show my scale, because I know I'm going 1 in the x direction, and in the y direction each block represents 2. So let's graph it. So if I go to -3, I'm going to go to 9. So 2, 4, 6, 8, 10, so right here. For -2, I'm going to go up to 4, which is going to be here. For -1, I'm going to be at 1. 0 at 0. +1 at 1. 2 at 4. 3 at 9. So this right here is the parabolic shape. Now, it's a polynomial, so it's going to be a very smooth curve. Oftentimes, that doesn't look super smooth. That's just a shaky hand, I think. There you go. You want to have a nice curve to it. Some people like to put a V, and that is not the actual shape of a parabola. It's more curved than that. It does come down to this point here that is called a vertex, but more about that later. To draw this properly, I need to make sure that there are arrowheads. Now, sometimes in test-making programs or sometimes in textbooks, they don't have those arrowheads, but I just want to assure you that it is very important that you put those arrowheads in, because it means it continues on in both directions. So this is the basic shape of a parabola. The way that I kind of do a quick way is I go from the vertex and I go over 1 and up 1. Then I go back to the vertex and I go over 2 and up 4. And then I go back to the vertex and I go over 3 and up 9. That way I don't have to get this table of values all the time. So the graph of every quadratic function is called a parabola, like I mentioned before. So here are the characteristics. The vertex, let me just zoom out so we can look at both of these things. The vertex is the highest or lowest point. Now in this case, the vertex is right here, and that's the lowest point of the parabola. The vertex is a minimum if the graph opens upward, and the vertex is a maximum if the graph opens downward. Sometimes we're going to see graphs that open up that way. The parabola is symmetrical about a line called the axis of symmetry. The axis of symmetry intersects the parabola at the vertex, and the x-coordinate of the vertex corresponds to the equation of the axis of symmetry. So if I'm just going to go in here, I'm going to draw in my axis of symmetry. It means if I put in a mirror right here, where I'm drawing this red line, it means it's the same on the left-hand side as it is on the right-hand side. So in this case, the axis of symmetry is going to be x equals 0. The domain is all possible x values, and I'm just going to give you a little helpful tip and trick. The domain of a parabola or of a quadratic is always going to be x is an element of the reals, because we extend in both directions infinitely. So we can go to infinity in this direction or infinity in that direction, and the parabola will just keep on opening and opening and opening and opening until all the x values are covered. The range is all possible x values. The range depends on the position of the vertex. So for this, only x values that are greater than 0 will be touched on by this graph. The graph doesn't exist, this specific graph does not exist below the x-axis, or it does not go into negative y values. So in this case, the range is simply going to be y is greater than or equal to 0, because it does include that 0 point right there.